when naming a compound, it's really important, it's very important to keep track of the last couple letters of the name. Let's do an example here. The N at the top is nitrogen. Often we call it atomic nitrogen. Atomic nitrogen because there's just one of them, whereas N2 would be molecular nitrogen. Now here's where the ending of the words start to come into play. Nitrogen with a 3- charge is called nitride. NO3 with a -1 charge is called nitrate. And NO2 with a -1 charge is called nitrite. Notice the endings there. Notice the endings, IDE, ATE, ITE. If the name of a chemical ends in IDE, it's probably based on an element from the periodic table, a single atomed element. However, if the name ends in ATE or ITE, then it's probably a chemical based on a polyatomic ion. And you need to look the polyatomic up. Let's do an example. If I had the name of calcium nitride, and I wanted to write the formula, the IDE ending tells me it's going to be based on the 3- charged nitrogen ion. So I would write calcium with its 2+ charge and nitride with its 3-. By multiplying the charges together, I get the lowest common multiple, and that tells me what to aim for both the positive half and the negative half of the ion. So 2 times 3 is 6. So how many of the calcium would I need to get a +6? Well, I would need 3. How many of the nitride would I need to get a -6? 2 of them. So the final formula is Ca3N2. You always leave off the charges when you write a formula, unless the overall compound has a charge, in which case it's a polyatomic ion. Well, now, on the other hand, I just wanted to get another example in here where there's room. If I had calcium nitrate, the ATE ending right here, would tell me that it's based on nitrate, NO3. So then I would write calcium, which is a 2+, and nitrate, which is a -1 charge. Well, they're going to meet at 2. 2+ times a -1 is going to give me 2. So how many calcium do I need to get a +2? 1. How many nitrate do I need to get a -2? I need 2 of those. Note how that looks like NO32. To get past that, you put your polyatomic in parentheses, and that lets you know that there are 2 NO3s. So the final formula, you don't write 1s. The final formula is CaNO3 for calcium nitrate. One last thing. Going back over to here, notice that NO2- was nitrite, but NO2 without the minus is named on a different set of rules using Greek prefixes to tell you how many of each element you have. You use these rules whenever you're dealing with a molecule that is made of 2 or more nonmetals and is neutral. So here you would have nitrogen dioxide.